The agenda of this particular topic is basically four topics. One is what is the design philosophy of the RISC? What is RISC? Reduced instruction set computer. Reduced instruction set computer. The ARM is basically a reduced instruction set computer. Okay. What is the design philosophy we are going to use for designing the RISC devices? Second topic is the ARM design philosophy. When we are designing the ARM, what are the design philosophies we have to follow? What are the parameters we have to consider? That is the second one. Then what are the different embedded system hardware? What are the different embedded system software? These are the four topics which are mainly covered in this particular topic. That is module 3. Now, I have already explained this one. ARM processors are a family of central processing unit. It is basically a family of CPU, but it will be called as a reduced instruction set computer. Means number of instructions are reduced. Number of instructions which are available in this particular type of architecture are less. ARM stands for Advanced RISC Mission. Already explained. What are the major parameters we are considering? What are the major advantage of ARM? First one is power efficiency. Because number of instructions are less, it will be executing fast. Okay, it is giving you power efficiency. ARM processors are designed to be power efficient, which is important for mobile devices that are limited by battery life. Any device which is using the battery life, which needs a power efficiency. It may be your laptop, it may be your mobile, it may be your smartwatch, whatever you are going to use currently, there are battery powered devices. Okay, so we need to have battery power at least for 1 day. At least for whatever the device they are using, even a smartphone. Each and every time we have to charge it out. Once you charge it, at least it should stand for 1 day so that next day we can charge it once again. Even mobiles also, they are chargeable mobiles, battery is available. We need to charge them so that it will be available for 1 day. Basically, when you look into wireless devices, any wireless device, portable devices, assume that one medical devices will have it. If you want to go for scanning, okay, scanning, now you can go to the hospital, go to the particular hospital, there they are going to give you the scanning, they will give the report after some time. Nowadays, what is happening? Hospital will they will be sending a message saying that we will come to your home. We will take all the details from you, then we are going to give the report. You may get a message saying that just for 499 rupees, your health checkup will be done. We will be coming to your home itself. So how they will do? How exactly they are going to do that one? They will be bringing the portable devices. There are battery powered devices. There are battery operated. Okay, so using those battery operated, they are going to come to your location, they will take all the parameters and they'll go back and they'll submit that to the hospital or which are the diagnostic centers, and there they are going to generate the report on that. Simple example for this one is your BP operator. Have you ever checked this digital BP operator? We used to conduct the health checkups in the campuses. There they are going to bring the blood donation camps, eye camps and all we have conducted. There they used to bring a digital device, it's a battery operated. The pulse oximeter, what we are going to call. Pulse oximeter, you will have checked with the pulse oximeter, it's a small battery which is available. So it's a battery power. Okay. So we need to have a device such as that it's a battery powered device where battery life should be there for longer duration. So power efficiency is one of the major constraint when you are designing the ARM device or ARM core. Second one is it should be cost effective. Okay, obviously whichever the device which is available in the for public, okay, in the market, most of them it should be cost effective. Blindly you cannot go and pay the money whatever they say. Even though so many devices are available, so many components are available, so many electronic gadgets are available, we always look for the what is the cost of that one. ARM processors are often less expensive than other type of processors, which can make them a cost-effective choice for the manufacturers. So These are the major two constraints. One constraint, one parameter, it should be power efficient. Second thing is a cost effective, and it should be fast. It should work fast. It should not make us to wait for the longer duration. Now, looking at this diagram, we can easily find the difference between CISC and RISC. CISC is the other type of the computer, complex instruction set computing, or complex instruction set computer will call it. What we are discussing is RISC, reduced instruction set computer. The other type of this complex instruction set computer. The diagram itself shows that one, what exactly the difference. Okay, we have a hardware, we have a software. This is the hardware, this is the software. In both the cases, in CISC also we are going to have the hardware and software. In RISC also we are going to have the hardware and software. Okay. Compiler is a software. Processor is a hardware. CISC is having compiler and the processor. RISC is also having the compiler and the processor. The major difference is in RISC architecture, the difficulty or complexity is kept at the compiler location, at the compiler stage. Hardware is not complex. Hardware is simple. The processor is simple, but the compiler is complex. But in CISC what happens? It's quite opposite. In CISC it is quite opposite. The complexity is kept in the hardware. Complexity is kept at the hardware design, but the simplicity is kept in the compiler design. Okay, so there is a major difference. You can see that one CISC, the processor is very complex. Designing the hardware is very complex. Okay, but in RISC, designing the hardware is very simple. They have made it very simple, such a way that it can easily execute. It can easily execute and it can easily handle. RISC, the ARM core uses RISC architecture. RISC is design philosophy aimed at delivering the simple but powerful instruction that execute within one cycle. Very important. Within one cycle, within single cycle, it can execute that one. I think you might have come across the cycles. Different type cycle in the sense we will be having a pulse which is either it may be a square wave or it may be a sine wave. This is one cycle. The instruction has to complete its execution within this time duration. T on and T off. T on and T off will put together, we'll call this a one cycle. Whatever the instruction we are going to execute, that should complete within this time duration. The T on may be 60%, T off may be 40%. T on may be 90%, T off may be 10%. Okay. T on may be 30%, T off may be 70%. Depends on the instruction. So, but the entire instruction has to be completed within one cycle. But when you look into the CISC architecture, it may take 2 cycles or it may take 3 cycles. It may take 4 cycles also, depending on the instruction. CISC we cannot ensure that one it will execute within one cycle. But RISC will ensure that one each and every instruction will be executed within one cycle. That's the major advantage. Within one cycle, in a sense, obviously it is faster. Here it is taking 4 cycles, but here it's taking 1 cycle. Okay, it may be taking 4 nanoseconds. This will be taking 1 nanosecond. Okay, this is RISC. This is CISC. Assume that when I'm having a null instruction in both the cases. In CISC also I'm having null instruction. In RISC also I'm having null instruction. Multiply 2 different register and store the register in the 3rd register. I will be giving mul R3, R1, R2. Just an example. R1 and R2 will be multiplied and the result will be stored in R3. Okay. So, if I apply this mul instruction in RISC, the entire thing will be executed in one cycle. But if I apply the same thing in RISC architecture, it may take 2, it may take 3, it may take 4, depending on the type of the CISC architecture, type of the processor you are going to use. That's one advantage. Okay. The RISC philosophy concentrates on reducing the complexity of instruction performed by the hardware. Complexity is reduced in the RISC. There is no complexity in the processor, no complexity in the hardware. The complexity always lies in the compiler. So with this diagram, you can easily execute what is the difference between CISC and RISC. Okay. Complex instruction set computer relies more on the hardware for instruction functionality, and consequently the CISC instructions are more complicated. Instructions are more complicated in that one, but in RISC the instructions are less complicated. Any doubt, any clarification? If you know this diagram, you can easily explain what is there. Okay. So the table gives the clarity, the entire difference between the CISC and the RISC. Okay. Left hand side we are having the CISC, right hand side we are having the RISC. CISC, complex instruction. CISC is a complex instruction. Takes multiple clock. As we explained in the previous slide, it takes more than one clock. But in RISC, it's a simple instruction. It's going to take only one clock for execution of the instruction. Emphasis on the hardware. Hardware complexity is here. Emphasis on the hardware. The CISC is hardware complexity. RISC is emphasis on the hard software. The complexity is in the compiler. Okay, that's the two difference already I explained. What is the next? Instruction executed by the processor. Instruction executed by the processor. RISC instructions executed by the hardware. Okay, instructions executed by the hardware. Variable format instructions, single register set, and many instructions. It may be having variable format instruction, like the format between 2 operands, 3 operands, 4 operands, like that they won't have that. That is what variable format instruction. RISC, fixed format instruction, multiple register sets, and few instructions are there. We will see to that one how the instructions comes into picture. So this is the major difference between CISC and RISC. Many instruction and many addressing modes, fixed instruction and few addressing modes. That is the difference. Conditional jump is usually based on the status register bit. Status register bit. Status register bit, that is CPSR. Current program status register. I told you. In that one, we are going to have NZCBI. Negative, 0, carry, overflow, interrupt. NZCBI, we call that. Negative, N is negative, Z is 0, C is carry, V is overflow, I is interrupt, Q is fast interrupt. Q is also there, we'll see that. So, in CISC, conditional jump is usually based on the status register bit. What is the status register? If 0, if carry, if overflow. Okay, that is it. But in RISC, conditional jump can be based on the bit anywhere in the memory. Anywhere in the memory, in the 32 bit, whatever is the bit, based on the condition, it can take that. IFT also will follow. Memory reference is embedded in many instructions. In many instructions of CISC, it always keeps the memory. Memory reference is going to take. Memory reference is embedded in the load store instruction. See, load instruction, store instruction always deals with the memory. That means, in the other way, RISC processor, every operation is based with respect to the register only. You should always use the register to perform any arithmetic operation, logical operation, any operation. You have to always use the register. But in CISC, what happens? Registers also you can use, and on memory also you can operate that. See here, I'll give the example. Num1 db, okay, something like 0x1234. Num2 db 0x2222. Assume two numbers I have given. Listen here. It's not db. This dw or dw I can give. I think microcontroller you have studied. Controller 8051. 8051 you have studied now. Okay. I have declared two variables. One is num1, num2. If you want to operate this in CISC, you can directly operate num1, num2. But if you want to operate the same num1, num2 in RISC, first those two should be taken into registers. You should copy that one to register 1, copy the second one to register 2, register 1 and register 2 you have to operate that one. Then only finally you can store it back to the memory. That means RISC will not directly operate on the memory. You should always take them into the register, operate them, then finally you load it or store it. That is what the instruction. This memory reference is embedded on load and store instruction only. First you have to load it, operate it, then store it back. That is this. But in CISC what happens? No need to load, you can directly operate on the memory. Okay. Almost all instructions they can operate on the memory. That is what is mentioned. Memory reference is embedded in the many instructions. Many instructions. You can go for load, you can go for